There you go.
All right.
We have known Amanda for, I'd say 2 or 3 years now, Amanda.
Yeah,
we had a mutual friend, and it culminated this summer when you offered a camp, which was amazing. A camp using the MindLabs app and Explore Interactive. So Amanda is coming to us from Lafayette, from Purdue, and she has created something really cool. I'm excited for her to share it with you. Thank you, Amanda.
Yes, thank you. That video was put together by Purdue after we got one of our SBIR grants, which is a small business grant for innovative research. So our company's gotten one from both the NSF and the NIH, and that's contributed to the work that we've done here. And I'll be mostly talking about augmented reality, so I was glad to hear that there are some fans there. And like John, I do also a lot of times get in character when I'm, doing presentations and clip in my. It's really there on this side, but I clip in one that makes it a lot more obvious. So what I wanted to do is just do a quick intro to augmented reality, talk about how I think AR integrates with engineering design, show off sort of what we're proud of, which is our collaboration and engagement, and then talk about also how we're working on incorporating literacy and writing into what we're doing with AR. And then lastly, I'll point you to a resource if you want, if I sell you very well on AR, where you can find a million different AR things to look into to investigate further. So just on a very basic level, a lot of people have a little bit of confusion between AR and VR. So AR would be things that are existing in the world or the space that you see around you, whereas VR is shutting off everything, and everything you're seeing is in that virtual world. So a couple of examples here. We have, looking at a card, like this is what we're showing in the video, looking at a card and seeing something appear over that card, or in a larger scale, seeing things all around you, like in this space here. There are really big differences in what you need in terms of devices to execute that. So AR really can be just the handheld devices that you might already have in your classroom or maybe have in their pockets. I also think there's big differences in how the students are able to interact with each other and communicate with each other while they're engaging in the activity. So there are some pretty big differences between the two. When it comes to our preference, which is AR, I wanted to pull up this quote from Tim Cook that really, I think, brings it home. He says that AR is like the smartphone. Now, if you can imagine, like I can, the world before your smartphone, okay? And how I couldn't imagine why I wanted pictures on my phone, right? Like that was, and then the world now, right? And that's kind of, that's the type of shift between no phone and phone that Tim Cook expects with AR. So it is a big deal, and there's going to be so many cool things that happen around it. I just pulled together some of them. I know a lot of times we're thinking about readiness and getting kids ready for what they're going to see in the future. And these are the places, these are some examples of places that AR is either projected to be or is already kind of there. And so I like the bottom left where it's, I don't think it's quite there yet, but in terms of like a Zoom call where you feel like really with people, where you see their full body, right? And you're kind of sitting at a table. So communication features, design, whether it's more engineering or artistic design, even testing, right? All of these things have places where AR can really bring a lot of benefits in terms of expense of the experience, as well as just being able to zoom in, zoom out, interact in many different ways. So it's not just a learning tool, it's also the tool of the future, right, in the workforce. And this picture here, so they're showing this one down here, I had him looking at it through a phone, so an AR style phone, but moving towards, in the longer run, you'll see even these AR ones are showing them with glasses, though the glasses are more, see-through types of glasses. And then, in terms of interactive information, I think that's one of the places that we're seeing it earlier. So we can see, people viewing an exhibit through a tablet here, or having, if they're wearing some sort of Google Glass or one of those glasses type, seeing it helping you navigate the streets, or even in museums, looking at different, populating the skeleton with the outer skin of the beast there, and just providing additional interactive elements to the learning experience. So the research is there too. There's a lot of research around how augmented reality experiences can improve things like critical thinking, persistence, learning outcomes, retention, and motivation. And all of those things are really beneficial. And especially, I think we're focused in on the younger age group. So bringing those types of experiences in the younger age group. And what's not in there is also, it's just a bit easier to get there than maybe some of the other experiences. So whereas some really involved hands-on experiences could take a lot of setup and cleanup time for an elementary age teacher that doesn't have classroom space dedicated to that type of activity, could have STEM a lot more frequently and still feel like hands-on when it's in an AR environment that's designed well, obviously. This summer, what Edie was talking about was we integrated the augmented reality work that we did with the Boston Museum of Science and Engineering is Elementary. And really, they were really in favor of how the tools could enhance the engineering design process. And I'm going to talk about a couple places where using augmented reality can really extend and improve the engineering design process that you're probably all very familiar with. So as you know, to get these types of projects and experiences into the classroom, a lot of times they have to check more than one box, right? They have to check lots of boxes for teachers to be able to spend the time in the classroom on it. And one of the places where I personally believe that they fit in really well is addressing these SEL, some of these SEL boxes, right? So solution, self-efficacy, growth mindset, all of these things really can come into play in an engineering design type of project. So I wanted to just show you a couple of ways in augmented reality that could look. So here is an example of just a very simple design project, right? So here, make a circuit that lights up more than one light. And how would you do it? So this card is what's in the physical space, and these 3D pieces are what's in the virtual space for the child. And their objective is to figure out how to draw wires on their screen with their fingers to connect the circuit in a way that will make the circuit light up. Okay, and so they can do it actually more than one way. They could do it in series, like is here, or they could draw it in parallel, like is shown up at the top. What's really interesting, I think, about the way that this is showing up in augmented reality is it really shows you what parallel means probably better than a lot of visualizations of the circuits, right? You can really see that these really are sort of parallel connections, whereas this is what it would look like in the physical space, and this is what the Boston Museum of Science physical components did. So you can use augmented reality in the classroom where you don't have the ability to do physical builds, or as an accompaniment to physical builds, or a design part of the process before you go to physical builds. So understand, helping kids work through conceptual ideas before they go to the physical materials, so that when they get to the physical materials, maybe there's less issues with some of the basics, and they can go a little bit further with their physical projects. Or vice versa, they can do a physical project and come back into the virtual space and build something bigger and more elaborate than they'd be able to build in the physical space. So it kind of can go, it can serve on both ends if it's integrated with more physical projects. Another subset of the SEL considerations: communication, teamwork, collaboration, leadership, resolving conflict. All of those things come into play when you're doing group design projects. And I think probably you'd all say that mostly this type of work is done in groups. Agreed? Yeah, it's one of those places where we can really hit on these. And that's where I think a lot of digital tools so far kind of fall down on, in terms of allowing for this collaboration. And that's one of the things that we actually can do pretty well. So I wanted to just show you a quick example of how that might look. So we use these animations. So the cards that we use with our instance of augmented reality have this set of what we call idea cards. So this one that you're looking at is like this, right? And the kids view it under the app, and it triggers that animation that you see there. And to get to that animation, I literally cut open a switch with my dad and looked at it, right? This is how we kind of worked on building this. this card. And the idea is as well that even if the children are offline and they have access to these materials, they're still envisioning, you know, that little animation going through their head when they're working with these ideas and building how these ideas work. So this particular example would be after you've talked about open and closed circuits, and then you're demonstrating how a switch functions to open and close said circuit, right? And switches give a lot of opportunity for fun design projects that achieve specific goals. So one of the design projects that we've implemented into our set of curriculum is a design project around building an alarm system where you have different watches and they're all trying to set off one alarm. And so I wanted to show you an example, and I hope the video goes the same. I didn't see an option of like sharing my screen volume, but we'll hope it works pretty well. So the way we set up the design process in the materials that we provide is you have criteria and constraints, you have available materials, and then you try to build this particular a solution for this. So I'm going to play here because I think that the idea of collaborative AR can be a little bit confusing. So I'm going to play this a little bit so you can see it in action and maybe narrate it a bit as well, although you'll hear me narrating as we go here. So.
Okay, there's the battery. Pixie, can you add a light bulb?
Okay, so I'm going to pause it here for a second. So the child across the table has their own card that they are looking at. She's looking at her own card here, right? But they'll both see the same thing going on in their space. So both the children see a battery right in front of their particular card.
Yeah.
She's going to add this light bulb piece in, and as soon as she adds it in, then her partner would also see this happen.
Pax, do you see her drawing the wire? Oh, you're drawing the wire.
So they can see each other's actions.
Okay, now kids, can you work together to put a switch in there for the light? Why don't you both put a switch in and see how to make it work for each of you?
Look at my switching.
How are you going to wire it in there, Pax?
So you can also see how he's moving the wires with his fingers to turn it on.
Let's see if that works. Well, that way it has to have both switches on. Okay.
So the challenge is to make this switch, each switch turn the light on, right? Versus having them to both trigger the light.
Figure out how to wire it where you only need one switch?
Yeah.
Or I mean, only one switch needs to flip?
And so this is, you know, they're having to sort of
How would you wire it so that
both
only one
consider
switch
how
needed
they
to
work.
flip?
Now, this wasn't set up in a classroom environment. In all fairness, these are my two kids working on this, but so they didn't go through the whole engineering design process and fill out their notebook or any of that around it. But they
How
are
would you wire that switch so that
still both trying to solve this problem.
Pax is putting one in for you too. Oops.
It
Good.
So one game, two different places. They could be remote as well. But either way, they can be remote or in the same space. They have their own set of cards, so they're not sharing manipulatives, and they are seeing the projects come to life together. So that's how our collaborative functionality works. Whoops. So building on that, another element that we try to hit on with the AR that we're working on is around the critical thinking, cause and effect, and reasoned decision making. So one of the things that we believe is that once kids understand the principles, they make good choices when they find a problem. So another element that we really hit on is troubleshooting. And this is one thing that I think is really, really hard to do in the classroom, because you're setting up you can't go a bunch and set up, 6 different instances of something that's broken and then have the kids all have a chance to try to fix it. I did it once for my kids and it took me like 30 minutes to get one of them set up for one set of kids to look at, right? It's just very difficult. So the idea is that within an AR environment, you can set up a bunch of practice troubleshooting instances where the kids can go through and find the problem with the circuit and repair it themselves. And that gives them a little bit more of the repetition that can build the understanding of the concepts that's really hard to replicate in the physical space, right? It's just very hard to replicate. So for example, here be a show the same like two sets of parallel and series circuits, but there's something wrong here, right? And so do you all see what's wrong with this circuit on the left? Why it wouldn't light up? So this one's lighting up, this one's not. Anyone? So the problem is that there's a wire here between these two legs of the LED. So there's a short circuit all the way around here. It's skipped, the energy does not even go into the LEDs because it's skipping the going up to the LED. So there's this extra wire in between these legs. You notice it's not here, that once you strip that extra wire out, and those are the things that they look for. When you build with, especially like squishy circuits, this happens a lot because they take their LED and stick it into one ball, right? And that means there's a path for that electricity right past the LED. So when they work on these things before they hit the Play-Doh, then you can talk about how the Play-Doh does one thing and the clay does another, and kind of have a lot of awareness around those ideas. So we will move that middle layer.
We do have a question coming in the chat. Are these programs compatible with Chromebook?
So the way that the cards are read and the way typical Chromebooks work with forward-facing cameras facing the user instead of away from the user, as well as not being touchscreen, the app is only on handheld devices, not on Chromebooks. So Chromebooks are evolving a little bit towards that way, right? Being touchscreen, having forward-facing cameras, and we hope that when that's more prevalent, that will be available. But any phone, pretty much any phone that's around, and most iPads have enough tech, because we actually use an AR that's lower tech to get the image recognition. So most tablets work. The last piece, I know I'm at 6:40 and I cut out half my slides. So, and you guys gave me 5 extra minutes. So with all that, the last piece that we're working on actually going into the future is building some scaffolding into that collaborative space to try to bring in the engineering and design notebook right in line with the design experience. Now we're writing grants to do that right now, so I'd love to hear how important that would be to you. But what we envision is we have a lot of our curriculum is in a PDF form that you can write on and draw on, but we'd kind of like to have that more integrated with the design process to guide kids through it a little bit. But there's a lot of opportunities, as you probably well know, in these design projects to do writing around either the troubleshooting process, right? So there's a lot of pieces in the troubleshooting, or in testing and building your design. Does it meet your requirements? What else do I need to do? How could I fix it, right? To work on those. So those are just kind of some examples. And then the reflection piece, which is so important as well. So all of these things are things we want to integrate sort of alongside the design process within the app to get a portfolio kind of feel, as well as have these processes and reflections documented. This was one of the students that Edie brought us in terms of that worked on this in the camp. She sent me this screenshot to tell me how much fun she had working on her design experience. So I really love that. She obviously put in a buzzer and a fan, and these are all pieces that are in the set as well. The light bulb, different batteries, and the switch. And she was an awesome student and had a really good time. In terms of self-efficacy, we didn't have huge data points because we had to collect both at the beginning and the end, but everybody moved more towards having some efficacy. Not I want to be an engineer necessarily, but if I wanted to, I could. So an improvement towards I have the capacity to be that kind of a person. So I did promise other AR tools. So I was giving you a highlight of what we believe is important and what we're working on in our app, but there's a whole subset. So I wanted to share this particular sort of influencer. So her name's Jamie Donnelly, and she has a blog called AR, VR, and EDU. And I actually just got her this is brand new, like hot off the presses today, this immersive classroom book. So it has a lot of different AR opportunities, and it's very applied. She's a teacher, a former teacher herself. And she also right now in March does a every day. She sort of covers a new AR app, and that's in process right now. So you can go and sort of follow her, and she is just outstanding, does a lot of speaking at conferences as well. So here's what's in our app, a bunch of different activities around these topics, some creative design projects that are more open-ended. And I'm only 2 minutes over, so you all are ready and you've earned your AR engineering badge. And thanks for having me today.
Well, Amanda, it was awesome to have you. And I just put in the chat too, we have your MindLabs kits available at our shop, and anyone on this call who would like to try them out, I will be happy to give you one. So our pop-up science shop is open Saturdays from 10 to 1. All you need to do, once you get the kits of cards like Amanda showed you, you need a tablet, and then you need to download the MindLab app. But all the instructions are there. So it's a really fun thing to play around with. And Amanda, we're going to keep tabs with you and everything, how this is developing, because it seems like it's just going to go, this is the direction for STEM education to take, right?
And I'd love to hear your guys' thoughts on specifically this sort of engineering design journaling idea that we're putting into our next grant, and sort of how important that is. I really don't think there's anything out there that does a great job at that at all, even without AR. But anyways, that's what we're building towards. So thank you again. And I don't want to steal more of Sarah's time. So
we're happy to introduce you to everyone. If you are directly interested in this, please email me. I see there's a comment from Lara Bates, so just let me know, and I'll be happy to connect you or get the kits to you, okay? So next up, Holly, thanks again, Amanda. We really appreciate you joining us. And we loved your camp. All the kids loved it. It was great. I loved it. I sat in a lot of it, and I was like, I wish I had this exposure.